Okay. Very good day to my dear students of class 11 science. This is a short video which I would like to, using this video, I would like to just give you a basic knowledge about how to write electronic configuration, electronic configuration. But in to be able to write the electronic configuration of the elements, we over here in class 11, we must be able to understand a principle which is called Aufbau principle. Now, in the Aufbau principle, if you see a class 11 textbooks, you will find that over there are alphabets, small alphabets like S, P, D and F. Now, what are those S, P, D and F? I would like to explain you today very briefly and shortly by this short video. Now, if you look at the board over there, I have written down this as a heading over there, structure of atom. This part I have taken from the chapter structure of the atom, where very briefly I will talk about Schrodinger, I will talk about orbit, subshells, orbitals, S, P, D and F, little bit about quantum numbers as well, and then I will jump directly to write the electronic configuration using the orbitals S, P, D and F. Now here, let me begin in detail now. As you can see over here, Schrodinger, there is a very famous equation in physics as well as chemistry which is called the Schrodinger wave equation. Now in this Schrodinger wave equation, this comes under wave mechanics, where this person is Schrodinger, he considered the electrons as three-dimensional waves. Three-dimensional waves, that is very, very important, not a particle. Schrodinger considered electrons as three-dimensional wave which is present in electric field of the positively charged nucleus. The nucleus is creating an electric field, and in that electric field, what is present? A wave is present containing the electrons. This is what Schrodinger has told. Now, based on this concept of Schrodinger and the quantum numbers are N, L, M, S. These quantum numbers I will discuss later on in detail when I do the chapter in detail. Now, when the quantum numbers were solved mathematically, by using mathematics, then they came to the concept in much more detail. We have now learned what is orbit. After that, what is orbit? Orbit is nothing but it is well-defined circular paths. We have learnt about orbit in our junior classes, orbit or shells, but here well-defined circular paths are orbit, represented by English alphabets, capital K, L, M and so on, or 1, 2, 3, 4 and so on. That is orbit. Now, next we have a concept which is called subshell. Now what is a subshell? Subshell is something like an orbit. It is an area which is present inside an orbit. It is represented by small alphabets like S, P, D and F. S, P, D and F are subshells which are present where? Inside the orbits. Now, the S subshell, each S subshell has a capacity of accommodating 2 electrons. Then we have P subshell, it has a capacity of accommodating 6 electrons. D subshell 10 electrons, F subshell 14 electrons. So, this is the capacity of all these subshells over here. After the subshell, most importantly over here is orbital. Orbital is a very, very important word to be understood. Now what is an orbital? Orbital is a region in three-dimensional space around the nucleus where the probability of finding an electron is maximum. So if you want to find an electron, if you want to know the probability of finding an electron where it is maximum, then you have to talk in terms of orbital. Now, for the S subshell, it has one orbital. So, for orbital, I am making one box over here. And one box contains 2 electrons. One orbital can accommodate 2 electrons. One is clockwise, one is anti-clockwise. So, you can see one half arrow pointing upwards, another half arrow pointing downwards. Similarly, if you look at P subshell has got 3 orbitals. So, 3 orbitals, Px, Py, Pz. The names have been given for the p orbitals. It is px, py, pz. Regarding the shape, I will discuss later on in detail. Then after that we have D subshell, which has 5 orbitals. 1, 2, 3, 4 and 5 orbitals. These 5 orbitals are named as dxy, dxz, dyz, dx square minus y square and dz square. Now, these d orbitals, each one of them, each orbital can accommodate 2 electrons, so that gives a total of 10 electrons. So as you have seen over here, the s subshell can accommodate in its orbital 2 electrons. The p subshells having 3 orbitals can accommodate 2 plus 2 plus 2, that is 6 electrons. It is confirmed over here. And then the d subshell which has 5 orbitals, each orbital 2 electrons, that gives a total of 10 electrons. Similarly, if you look at the f subshell which has 7 orbitals in it, there are 7 orbitals, each orbital 2 electrons, it will give a total of how many electrons? 14 electrons. The shape of f orbitals are quite complicated. D orbitals are also complicated. P orbitals are dumbbell shape and s orbitals are spherical in shape. Now, I will quickly jump to the principle in order to teach you how to write down the electronic configuration of the elements now. Please follow and try to understand carefully. Okay, now dear students, you can see on the board over there, I have written the word Aufbau principle. Now, if you look at this, you might not understand anything, but let me explain you this thing very clearly. Here you can see alphabets S, 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 1S, 2S, 3S, 4S, 5S, 6S. Then 2P, 3P, 4P, 5P, 6P, 3D, 4D, 5D, 6D, 4F, 5F, 6F. Now, as I have told you, these are subshells. S subshell, P subshell, D subshell and F subshell. Okay. Now, 1S subshell is closest to the nucleus. It is closest and it will possess minimum energy. Now, according to the Aufbau principle, electrons occupy the orbitals which possess minimum energy. And then as number of electron increases, the extra electron, the increasing number of electrons now start occupying the orbitals or the subshells which possess higher energy. So in this manner, to understand this, it is very easy. First you write 1s, 2s, 3s, 4s, 5s, 6s, this way. At the side, in the examination also you can write it 1s, 2s, 3s, 4s, 5s, 6s. Then you write 2p, 3p, 4p, 5p and then 6p. Then you can write 3d, 4d, 5d, 6d. Then you can write over there 4f, 4f, 5f and then 6f. Then you cross it this way. Diagonally, you cross it this way. Cross it this way. Now, I'll tell you what is the meaning for crossing these orbitals in this manner. It is very, very simple. You don't have to get excited or scared over there. Now, see. You start from here. You start from here. Go this way. 1s. 1s. Then go back over here. 2s. Go back over here. 2p, 3s. Then go back over here. 3p, 4s. 3d, 4p, 5s. 4d, 5p, 6s. 4f, 5d, 6p. Then 5f, 6d, then finally 6f. So this is how, as you move from 1s towards 6f, the energy of the orbital is increasing. So I am writing the increasing order of energy of the orbitals now, like this. 1s. 1s. After 1s, I write 2s, then there is 2p, then there is 3s, then there is 3p, then there is 4s, then there is 3d, then there is 4p, then there is 5s here, then I go to 4d, then 5p, then 6s, then there is 4f, 5d, then there is 6p, then 5f, then there is 6d, and then finally we have 6f. So when you move from 1s towards higher orbitals, the energy of the orbital is increasing. That means from 1s towards 6f, the energy of the orbitals increases slowly. So the different orbitals in the increasing order of energy is given over here. This is the increasing order of energy. Increasing. It is called increasing order of energy of orbitals. Increasing order of energy of orbitals. That means 4d has higher energy than 5s. 5s has higher energy than 4p, and so on. So we can put a symbol between them, less than, less than, less than, less than. You know, you can put this way right till the end over there. Now, this is called the Aufbau's principle. This is called what? Aufbau's principle. According to this principle, electrons fill the atomic orbitals in the increasing order of their energy orbital. That means the orbitals which possess lesser energy, they are filled up first, and then as the number of electrons goes on increasing, the electrons start occupying the orbitals possessing high energy slowly. So this is what I have told you, it is called Aufbau principle. Now quickly, very quickly, just after Aufbau's principle, later on I will be teaching you a rule which is called Hund's rule, H-U-N-D-S, Hund's rule, Hund's rule of maximum multiplicity. You will come across this word in the chapter atomic structure. So where according to this principle, Hund's rule, as far as possible the number of unpaired electrons in the orbitals of a given subshell is maximum, and the unpaired electrons have parallel spin. Okay, for example, if you see the unpaired electrons, they have parallel spin, but they are spinning in opposite direction. One is clockwise, another one is anti-clockwise. So this was Aufbau's principle and Hund's rule. Now what I am talking about Aufbau principle, I mean to say that if there is an s orbital and we need to give two electrons, so I give one electron clockwise, another one anti-clockwise. This is s orbital. If I bring a p orbital, it has, p subshell has three orbitals, px, py, pz. There are three orbitals, each orbital two electrons. So if I start giving the electrons, so first I have to give the electrons single, single, single. Each orbital one electron each in clockwise. Then the remaining three of them anti-clockwise like this. This is how you put the electrons according to the Aufbau's principle and the Hund's rule. So that is how it is called Hund's rule of maximum multiplicity. Now I will go straight away and teach you how to write the electronic configuration by using this increasing order of energy of orbitals. You can pause this video and then write it down, practice it properly and learn cancelling this way. Cancelling this way diagonally, you know. If you learn this way, then in the examination at the side you can write it down and then write down this order. You will never make a mistake. For example, now let us do few examples for writing the electronic configurations according to this chapter atomic structure. Now this concept is definitely going to help you in understanding the S block, the P block elements, the F block elements, the D block elements, which you will be learning in class 12 as well. For example, if there is an element, for example, say, if I bring an element, for example, say chromium, chromium atomic number is 24. Chromium atomic number is 24. So let us write the electronic configuration of chromium by using this method of configuration. So I'll write 1s. S orbital can have two electrons, 1s, then 2s, 2s again, after 1s comes 2s, so 2s2, then after 2s comes 2p, so 2p, p orbitals, total number of electrons 6, 1s2, 2s2, 2p, 6, after 2p comes 3s, so I write down 3s2, after 3s comes 3p, so I write down 3p6, now I'll check what is the total right now. 6 plus 2, 8, 8 plus 6, 14, 15, 16, 17, 18. Now I can go still higher. After 3p comes 4s. It comes 4s, I can have 2 electrons here. So that makes it 20. After 4s there is 3d. So I'll put over here 3d and then first check the total. 6 plus 2 is 8, 9, 10, 10 plus 16, 17, 18, 19, 20. So, but chromium is 24. So I need to put over here 4 electrons. So 3d orbitals, they have got how many electrons? 4 electrons. So total is 2 plus 2, 4, 4 plus 6, 10, 11, 12 plus 6, 18, 19, 20 plus 4, 24. So this is the electronic configuration of the element chromium whose atomic number is 24. Now let us check. 1s, this is 2s, 2p, this is 3s, 3p, 3d. 1s over here subshell, it has 2 electrons, so I write 2. 2s total, this 2 and these 2. It is same. The second orbit, the second shell has total 6 plus 2, 8 electrons. 8 electrons over here. After that, the third shell, 3s2, 3p6 and 3d4. 6, 7, 8 plus 4, 12. You can put 12 over here, but before that 4s2. So over here we have got 4s2. This is 6 plus 2, 8. I can write over here 8 as well, no problem. Then there is over here 4s2, 2 electrons. Over here 3d4, 4 electrons. So this is how we get the electronic configuration of chromium. Now chromium, if you look at the periodic table, it comes under the D block: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. These numbers are nothing but these are called atomic numbers. This is the first series of the D block elements whose atomic numbers and the symbols are written over here. So by using the Aufbau's principle, this is how we write the electronic configuration. So chromium, the electronic configuration is here: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4 over here. The d orbital is having the last electrons in the d orbital. For chromium, the last electrons are entering the d orbital. That is why chromium belongs to which block? It belongs to the d block elements. Now let me do, this was example 1. Let me do another example. Let us take another element. For example, if I take calcium atomic number, if you see, calcium atomic number is how much? It is 20. Calcium atomic number is 20. So let me write down the electronic configuration of calcium by using this increasing order of energy of orbitals. So I will get over here 1s2, 2s2, 2p6, 3s2, 3p6. Let us check now. 2 plus 2, 4, 4 plus 6, 10, 11, 12 plus 6, 18. 3p6. After that 4s2. Now check the total. 2 plus 2, 4, 4 plus 6, 10, 11, 12, 12 plus 18 and 20. Now it is correct. This is the electronic configuration. If you add these powers, what are these? These are not powers. These are the electrons in the s orbital, electrons in the p orbital, electron in the s orbital, electron in the p orbital and so on. So if we add these numbers over here, it will come to how much? The atomic number of calcium, that is 20, that is the total number of electrons. Now this is how you write the electronic configuration of calcium by using the Aufbau principle. That is the principle I have just discussed that time. Okay, now if you look at the last shell of calcium, the last shell of calcium is 4s orbital. It is the s subshell. The orbital is 4s, 4 small s. Now the last electrons, the last 2 electrons of calcium are entering the s orbital. That is why this element calcium belongs to which block in the periodic table? It belongs to the s block. Which block? It belongs to the s block. One example I have done for the d block, one example I have done for the s block. Now let us do another example. Let me take one more example over here. Now I will take, for example, chlorine. Let me take chlorine. Chlorine, it's a non-metal, atomic number is how much? 17. So let me write down the electronic configuration of chlorine. Atomic number 17 means number of electrons is 17. So it becomes 1s2, 2s2, 2p6, 3s2, 3p. Now let's check the total. 2 plus 2, 4, 4 plus 6, how much? 10, 11, 12. 12 plus 5. I have to write 5 over here. That makes it 17. Now in junior classes you have to you wrote electronic configuration by this method, by magic number. 2, this 2 is 8, okay. 2, 8 over here, 6, 7, 8, 2, 8, 8 and over here calcium is 2. This is how you wrote. K, L, M, N. This is K. K, L, M, N. This is for calcium I am explaining. K shell, 2 electrons, L shell, 8 electrons. How 8? Because 2, 2. This is the same principal quantum number. 6 plus 2 is 8. Over here, S shell containing orbitals S and P, total is 6 plus 2. This is third one. Third one is, total number of electrons is 8 over here. And finally the last shell, that is N shell, 2 electrons. So this is how you applied in lower classes to write the electronic configuration. But now we have to use the principle which is called Aufbau principle, where electrons occupy the orbitals. The orbital having the minimum energy gets occupied first, and slowly as the number of electrons increases, the orbitals possessing higher energy is occupied. So in this similar manner, look at the electronic configuration of chlorine: 1s2, 2s2, 2p6, 3s2, 3p5. So if I group this like this, one is separate over here, so I put over here 2 electrons, 2s and 2p. This number 2 is same for s and p orbital. So 2 plus 6 is 8. 2, 8 over here, 3s2, 3p5. Over here you check 2 plus 5 is how much? 7. So the K shell 2 electrons, the L shell 8 electrons, and the M shell 7 electrons. Halogens, chlorine is a halogen, it has 7 electrons in its valence shell. Now, if you look at chlorine, which has 7 electrons in its valence shell, the last shell over here, the last orbital is a p orbital. The last subshell is a p orbital. That is why chlorine is an element which belongs to the p block of the periodic table. So, I hope my dear students, you must have understood how to write the electronic configuration of the elements by using this Aufbau principle and keeping in mind the concept of Hund's rule of maximum multiplicity. You must always keep in mind that whenever you write electronic configurations, remember this order nicely, memorize it properly. 1s, 2s, 2p, 3s, 3p, 4s, 3d. 4s has lower energy than 3d. Then 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 5f, 6d and 6f. Now, one more thing I want to discuss before closing this coming to the end of this video is the orbitals. While filling the orbitals, let us see. One more example I will do and make things clearer to you. Suppose you have an element with, let us take for example, I give you an element, say iron, Fe. Iron has atomic number 26. If I am not mistaken, it is 26. It is 26. Now, let me write down the electronic configuration. It becomes 1s2, 2s2, 2p6, 3s2, 3p6. Look at this. 1s2, 2s2, 2p6, 3s2, 3p6. Then there comes 3d6, 4s2. 4s2, 3d6. I am writing 4s first because the energy of 4s orbital is lower. This is according to the N plus L rule. This rule I will teach you later on. For the moment you memorize this order. N plus, there is a rule which is called N plus L. The N plus L value of 4s orbital is lower than the N plus L value of 3d orbital. That is why the energy of 3d is higher, the energy of 4s is lower. That is why we place this order. Now let us check the total number of electrons in this electronic configuration of iron. 2 plus 2 is 4, 4 plus 6, 10, 11, 12 plus 6, 18, 20, 26. This is the electronic configuration of iron. Now, for my convenience, I can arrange it in this manner also. 1s2, 2s2, 2p6, 3s2, 3p6. Then I can write down 3d6, then 4s2. 4s2. Now, just to keep these 3's together, these 2's together, these 4 separately. Now, we can see 2 electrons here, 8 electrons here, over here 12 plus 2, 14 electrons here, and over here 2 electrons. Okay. So 2, 8, 14 and 2 electrons. That is how, according to the old concept, the concept which you learned in class 10, the electronic configuration K, L, M, N, that is the thing over here. Okay. Now, but keep in mind, in the case of iron electronic configuration, the last electron, the valence shell, is the last orbital, the penultimate shell, d orbital. That is why iron belongs to the which block? It belongs to the d block. It belongs to which block? It belongs to d block. Now this iron 3d orbital, if I write this way, The d orbital, I have told you, it has how many orbitals? The d subshell, it has 5 of them. So I am going to make 1, 2, 3, 4, 5. This is 3D. 3D subshell, you can say. Now there are 6 electrons in this case of iron. In the case of iron atom, there are 6 electrons in the 3D orbitals. So how to fill the orbitals? See, first single. 1, 2, 3, 4, 5. See, you fill the electron single. The electrons occupy the orbital single. And after that, once all the orbitals are half filled, then the remaining electrons get paired up. So 1, 2, 3, 4, 5 electrons done. How many electrons left? 1. So that 1 comes over here. So this is how you have to fill the orbitals in the valence shell. This is the example I have taken for iron. Okay, now I want to give you some work. Okay, now take randomly from the periodic table. You must have got your textbooks by now from the school. Take your textbook, open to the chapter periodic properties or periodic table over there, or what you call this atomic structure, and try writing down the electronic configuration of elements from atomic number. Say you can start writing from atomic number 10 to atomic number, you can go ahead till 50, you know, atomic number 50. By using what? By using the Aufbau's principle. Okay, now my dear students, I will stop my video over here only. Now, your work is to please go through this video carefully, and this video is going to, definitely it is going to help you in understanding the chapters, inorganic chemistry chapters, the S block elements and the P block elements. The next chapter I will be discussing with the video will be the first chapter in chemistry, which is called some basic concept of chemistry. Okay, thank you so much. Have a nice day.